Hey guys, so this is going to be the walkthrough for the second section of chapter 7, which is going to be about distinguishing elements of an experiment. And so specifically, it's going to address the learning objectives for 4, 5, and 6. And so that's the manipulation of the independent variable, the control of the extraneous variables, and how extraneous variables become confounding variables, and some information about that as well. So, just to review a little bit, the basic goals for establishing or demonstrating a cause and effect relationship is that you want to make sure that you're showing that the cause is happening before the effect happens, right? Otherwise, you can't say it's a cause and effect relationship, right? As if the effect is happening before the cause. So that is why we change a value or level or condition of the independent variable, and then we follow up with a measurement of the dependent variable so that we are showing that the change in the independent variable is followed by the change in the dependent variable. We also want to establish that one specific variable is responsible, meaning that independent variable, for changes in the other variable, which is the dependent variable. So you are trying to rule out that the changes in the dependent variable are caused by anything other than the independent variable. They're not caused by any extraneous variables, right? So part of how we do that is manipulation of the variables. So manipulation consists of determining the value of the independent variable. So, that if we're going to do high, medium, and low of something, or we're going to have, the example we used in the other video, we're going to have a non-violent video game group and a violent video game group. Whatever we're going to do, you got to decide what values, what levels, what conditions you're wanting to study, and then you create those treatment conditions that correspond to that. You create those groups so that you can compare them later, right? And so part of where that leads us is that it allows us to determine the direction of the relationship. Remember, we talked about directionality. So we manipulate the independent variable, and then we observe and measure the second variable, the dependent variable, to see if it is affected by that independent variable, right? And we determine what values we're examining in the independent variable. And because we are controlling that, we are determining that, that helps us say with confidence that those changes are what are affecting the dependent variable if we observe changes in the dependent variable. Now, when it comes to directionality, this is an example here. We have this example of ice cream consumption and temperature. So there is a correlation between ice cream consumption and temperature. They both go up and down together. That seems pretty intuitive, right? I mean, most people want ice cream more when it is hotter outside, right? So more ice cream when it's hotter. When the temperature is lower, people don't want ice cream as much. And so, of course, it makes sense that there's a relationship there. However, if you were trying to manipulate variables to determine a cause and effect relationship here, you can look at it like, would you increase or decrease a temperature as the independent variable to see if there's an effect on ice cream sales as the dependent variable? That makes sense, right? But could you do it the other way? Could you manipulate ice cream sales some way, like maybe handing out ice cream and in one group and not handing out ice cream in another group, and that would be your independent variable, to see if it affects a dependent variable of temperature. So let's see if handing out ice cream causes the temperature to go up or down. Well, obviously, it sounds silly to even say that. Obviously, handing out ice cream is not going to change the temperature. And so, because of that, you can see that that can only go directionally one way. If you're going to try to establish a cause and effect relationship here, your hypothesis is going to have to be, and your independent variable is going to have to be, that temperature is the manipulated variable, and ice cream sales or consumption is going to be the dependent variable, right? Another way of looking at this, another example is sleep or insomnia, lack of sleep, insomnia, and depression. We've talked about this example before in your book. Does insomnia cause depression to increase? Or is it the other way around? Is the relationship the other way around? Because there is a relationship there, but is it that the lack of sleep is causing the higher depression, or is it that the depression is causing the lack of sleep, right? And so if you wanted to study that and try to determine which one's the cause and which one's the effect, since you can't really manipulate depression levels directly, not without, treatment and things, and all of that's going to vary depending on the person, it would be much easier to, again, just like with the ice cream example, it would be much easier to manipulate the sleep. So keep people awake for a certain period of time in one group and not so much in the other group, or have multiple groups where there are varying amounts of sleep, right? And see if the depression levels are impacted in the groups that get less sleep. If that happens, then you would know that the manipulation of the sleep, that the lack of sleep is the cause and the depression is the effect, right? That's the one that's doing the influencing. If, however, you don't find that the depression increases with the lack of sleep, and if you're manipulating the lack of sleep, then it is probably the other way around. You can determine then that it is likely that depression is what is causing the lack of sleep. And so whether or not you find the expected results from your hypothesis tells you a lot of information. And you can determine cause and effect even if you can't manipulate one of the variables. Like I said, we couldn't really manipulate depression, but we can manipulate sleep. And so if we manipulate the sleep variable, that can help us determine if it really is having that cause and effect relationship on depression. So that manipulation component is very key in not only helping us determine cause and effect relationships, but also helping us determine the directionality of the relationship, which one's the cause and which one's the effect. So now we are going to stick with that same example of ice cream and temperature, and we're going to talk about the third variable problem. So manipulation can also be used to control those outside variables or those third variable issues that we talked about. So in this example, temperature is actually the third variable here, that ice cream consumption and temperature, like I said, have a relationship. Well, so does temperature and crime rate. The higher the temperature, the higher the crime rate. So as a result, ice cream consumption and crime rate also have a relationship. They both go up together, but it's not because those two are related. It's not that if we increase ice cream consumption, we increase crime, right? It's that there's a third variable influencing them both, and that is temperature. So in order to see this, though, in order to get at this, because logistically this makes sense, but in certain situations, you may not logistically see this third variable issue. It may be kind of more of a lurking variable. It may be a little bit sneakier than this, and so you don't even necessarily realize what's happening. But in order to control the influence of any extraneous variables or third variables, you can manipulate either of those variables, the ice cream consumption or the crime rate, and to see if there's a change in the other. So if we manipulated ice cream consumption, we gave, like I said, some ice cream to some and not to others, and see if the crime rate went up. Maybe we increase ice cream, we hand out ice cream more in this town, but we don't in the other town, or in this county, in this, or this school, this jail population, and this other jail population, we do ice cream in one and not in the other. And then you compare the violence or the crime rates or whatever you want to look at and see if it changes. Assuming that it doesn't change, then you would know that there's not a cause and effect relationship here, right? And you could do it the other way too. Yeah, you could manipulate the crime rate. That would be harder to do. You could implement like a police, massive police presence, right? And try to lower the crime rate. And if it did lower the crime rate, then you could look also to see if ice cream sales were affected. If they were, then you would know there was some kind of relationship. But again, assuming we all know by looking at this that that's probably not true, then we would know that there is not a cause and effect relationship here. And you would know that there's a third variable issue. And so that is how manipulating variables can help determine whether or not you have some kind of third variable issue or some kind of extraneous variable issue happening. So an experimenter manipulates the independent variable instead of just letting it change on its own. So yeah, we could let these independent variables change on their own, change naturally. But if we did that, there would be lots of other variables that could be influencing them while we're waiting, right? So instead of letting that happen, we manipulate it. We determine when the change is going to happen and what group's going to be, where. And by doing that, we are ruling out the influence of other variables, of other extraneous variables or third variable issues or anything like that. So there's also an issue with controlling here. If we are controlling the other variables other than the independent variable and the dependent variable, then we know that the observed relationship between those two variables is not contaminated by the influence of other variables. I really like the word contaminated here because I really feel like that gives you a good word picture of what we're trying to do in controlling these experiments. We're trying to keep the dependent variable, the thing you're measuring, from being contaminated by other variables. So a researcher must eliminate all these confounding variables, right? A third variable that changes systematically along with both variables is what is considered a confounding variable. So we want to show that the independent variable is responsible for the change in the dependent variable only, right? Only the independent variable. So if there's a variable that's changing systematically along with the independent variable, it could also be influencing the dependent variable. And if it is, then it is considered a confounding. Okay, so here's an example of confounding variables, kind of talking about what we were just talking about. So they give you an example in your book about seeing whether children prefer sweetened or unsweetened cereals. And in the example they used, the sweetened cereal was colorful, brightly colored, and the unsweetened cereal was a yucky tan color. And so they obviously did not prefer the tan colored unsweetened cereal. But the question is, was it because it was unsweet, or is it because it was not a very pleasing color? And so this goes back to what we talked about in the first video about how you have to separate these variables out as much as possible in order to be able to determine these cause and effect relationships. You need to separate. So here we need to separate the color from the taste in order to see which one which one they truly prefer. And so by making them both the same color, or making them both colorful is what they called it. And then having one sweet and unsweet. The only difference then is the sweetness, and that would help you determine which one they prefer, if there's a cause and effect relationship there. Now, that is assuming your hypothesis was about sweetness, but your book points out the color becomes the third variable, or the extraneous variable, or the confounding variable in this example, because you were looking at sweetness, you were looking at the taste, and so that was your independent variable. But if your hypothesis was based on color instead, and color was your independent variable, then you would want to keep them one colored and one not colorful, and you would want to make sure they were both sweet or both unsweet. You would want the taste to be the same, because the taste would end up being the confounding variable. So what becomes the independent variable and what becomes a confounding variable largely depends on your hypothesis and what your goal is of your study. So this kind of talks about what we were just saying, that extraneous variables become confounding variables. There's two criteria, or two ways that a extraneous variable is considered a confounding variable. Part of that is if it influences the dependent variable. So if it is impacting or contaminating, like we talked about, that dependent variable, then it is considered a confounding variable. If it's completely unrelated to the dependent variable and is not influencing it at all, then it is not a confounding variable. It's just an extraneous variable. So the example that your book uses is the types of shoes the participants are wearing. Those are going to vary, right? Everybody's going to have different shoes on. But unless you're studying something to do with shoes or feet, that is likely not going to affect your dependent variable. So in the examples we've talked about, the sleep and depression, or the cereal, or the ice cream sales and temperature and crime rates, the types of shoes that people are wearing is not going to affect that. It is not related to that. And so it is just going to be considered an extraneous variable. It is not something you have to worry about controlling. It is not a confounding variable. The other thing that a confounding variable has to do or be is it has to vary systematically with the independent variable. So if it's random, completely random, like the shoes people are wearing, and has no relationship to the independent variable whatsoever, it is also not a threat. It is not a confounding variable. It's just extraneous. So you can use common sense here. Your book talks about how if you were studying memory, you would want to consider the possibility of things like IQ, age, or distractions in the room, how if it's loud and noisy or there's lots of things distracting them, that could affect memory, right? And then obviously age and IQ. Those things are likely to become confounding variables because they are related to both the dependent variable and the independent variable. If not, then they are not those confounding variables. But those are an example of how it would have to be related to both in order to become a confounding variable. And so this is kind of what we were just talking about a second ago. The way to eliminate the confounding variable is to make them the same, right? So they put them both as colorful cereals. And then if they still prefer the sweetened cereal, then you know that it was about the sweetened cereal and not about the color of the cereal. And so this reflection is just trying to get you thinking about how these concepts can apply to your real life. So it's prompting you to think about some kind of problem that you encounter in life, and think about the extraneous variables that could be influencing your ability to solve that problem or fix that problem or address that problem. And then what could you do to reduce the influence of those extraneous variables? And this is, I encourage you to screenshot this and kind of think about this, because that is a good way of taking these concepts and making them real and applying them to your own life. I did want to talk about this real quick from your book, where it says, although the focus of an experiment is on the two specific variables, the independent and the dependent, there are thousands of other variables that exist within an experiment, and different individuals enter the experiment with different, like again, all of these different variables, backgrounds, ages, genders, heights, weights, IQs, personalities, all of that. And then environmental variables as time passes, room temperature, lighting, weather changes, people just getting bored or tired, their mood, they're happy or sad or excited, and then that fades, or they forget things, or they remember things, are triggered by things, they develop itches, aches, pains that distract them. All of those things can be extraneous variables. So they have the potential. All extraneous variables have potential to become confounding variables, but it depends on the type of variables you're studying and what your goal is. But it also depends on, again, whether it is actually related to or influencing the dependent variable, and whether it is related to that independent variable. Okay, and then I wanted to go, oh wait, I think I just went to, I didn't want to go to 7.3. Let me do the learning check real quick. So in an experiment, what is the purpose for manipulating the independent variable? I don't know if I showed you that on the screen. Okay, there we go. And so you can see the answers here. And hopefully you realize that it is not just one or the other, it is both. It helps establish the direction of the relationship, and it also helps eliminate the third variable problem. That's the two things that we talked about just now. Oh, I didn't mean to highlight that. And then in order to establish an unambiguous relationship between two variables, it is necessary to eliminate the possible influence of what? So what are we trying to eliminate the influence of? Hopefully you know from us talking about that just now, confounding variables. And then which of the following characteristics are necessary for that extraneous variable to become a confounding variable? And as we just talked about, if you read through these answers, it has to change systematically when the independent variable is changing. If it is not changing with the independent variable, then it is not a threat. It is not a confounding variable. It's just an extraneous variable. So that is it for 7.2.